Next example, we have x cubed plus x squared is equal to 81x plus 81. And we're going to solve this polynomial equation by factoring. So first things first, we want to make sure that this equation is equal to 0. So we're going to subtract 81x to both sides. We're going to subtract 81 to both sides. And we have x cubed plus x squared minus 81x minus 81 equals to 0. And we want to make sure our terms are in descending order, and it is. So we want to factor. How would you factor this equation? We have 4 terms. What's the name of that factoring method whenever you have 4 terms? We're going to factor by grouping, where we're going to group the first 2 terms together and factor out a GCF. We're going to group the last 2 terms together. So I'm going to split it in half. I'm going to chop it. Group the first 2 terms together. Give me a GCF. That's going to be x squared. What's left over? X plus 1. The next 2 terms. Give me a GCF. Tell me what is left over. The GCF is going to be negative 81. And then we're going to have x plus 1 that's left over equals to 0. When you factor by grouping, we want this to happen. We want the leftover component to match exactly. We want that to happen. So we're going to factor out one more time. What's in common? X plus 1. What's left here? We have x squared minus 81 equals to 0. This x squared minus 81, that can be factored. Difference of 2 squares. X plus 9, x minus 9. Don't forget about the x plus 1. Now using the 0 product principle, we're going to set each factor equal to 0 and solve. Therefore, x plus 1 is equal to 0, x is equal to negative 1. X plus 9 is equal to 0, x is equal to negative 9. And then x minus 9 equals to 0, x is equal to positive 9. And then if you want to on your own, you can check your solutions, go back and plug negative 1, then negative 9, and 9 back into the original equation to see if it checks out. And if it does, well, and for this example, all 3 solutions are the answers to this question. We're finished with this.